Ladies, start going. Stop, gentlemen. Nope, just take a seat and then join your groups. Look back here. Take a seat and join your groups. You sit down, kind of normally you're sitting in groups or listening. We're not even our group. We got a lot to do and not a lot of time to do it in. Problem solved. You need to be seated in your group. Tim.
Oh yeah, he's not even in that group. Come on, man.
Hey. In your group. 7, 6, 5, 4, 3. If you don't have a group, stand like long over here. Okay. We have a lot to do and not a lot of time to do it. Was this show's group yesterday? If you are not seated with the group that you were yesterday, stand up and line up by the wall over here. If you don't know what group you're in, stand by the wall over here. Byron, Kerwin, if you don't know what group you're in, stand by the wall over here. Justin, Kaylon, and over here. Kerwin, out. Out. And down to this. Here and Chelsea here. Try here. Cameron here. Chelsea here. I mean, not Chelsea, here. And Byron there. You can get started on the do now. Make sure your bags are behind your desk. Make sure your bags are behind your desk, out of the way. Timon and Chell is already showing professionalism, getting started. try utensil for shallow. Second time. Kelsey, do you? See, Cameron has completed first part of our do now. Moving on to number 2. One minute remaining. Your motor's already started on the second question. Seconds. That's your final answer in 2. One minute, 3, 2, 1. Waiting on 2 tables. Waiting on 3 scholars. Thank you. We had a lot of people who were not part of the group yesterday, and that's why I think I'm seeing a lot of blanks for question 2. I want you to have a chance to brainstorm and talk to the people in your group who did start this engineering design process with the hot air balloon. So we're going to take 1 minute to discuss what worked with the projects yesterday, what didn't work, and what problems do you expect to see today. 3, 2, 1, discuss. Back here, 3, 2, 1. Yeah, thank you, Niles. Thank you, Lauren. Thank you, Justin. And then sir, for turning around and putting your backpack behind your chair. What was our 2 biggest problems that we encountered? 1, 2, 3. Wait for 7. 1, 2, 3, 4, 5, 6, 7. Justin. Justin, you nailed it on the 2 biggest problems. Why? What was our reasoning as to why they did not lift off the ground? Joanna.
Because because the marble was sometimes too heavy to install.
Why didn't they lift up? She said the marble was too heavy or used too much oil. Okay, turn. Okay, cool. Page 2. We're going to do a little more research into what makes a hot air balloon lift so that your second design can be even stronger. Fill in the blanks. Key vocabulary. A measure of the amount of mass in a given volume. What word are we looking for there? This is a familiar word. This is a familiar word. Nia's got it. Density. Fill in the first blank. Density. The ability to float in air or water. This is a new term. Buoyancy. B-U-O-Y-A-N-C-Y.
Is that the bottom?
Buoyancy. Tyrese has got a great eye. It is also written at the bottom in the diagram. Buoyancy. Spelled really weird. Every time I type it in, I misspell it. But thanks to autocorrect, it corrects it for me. A substance that has no fixed shape, such as a gas or liquid, is a fluid. Air is a fluid, gases are a fluid, water, all liquids are a fluid. The state of not floating or sinking is suspended. You may have heard that word before. But not in this context. Not float, not sink, but stay in one place. As we read this quick excerpt about hot air balloons, I would like you to underline key vocabulary. Jerome, what are we doing as we read?
Underline key vocabulary.
Help you out, Jordan?
Underline key vocabulary.
Underline key vocabulary. Let's go. Follow along, pens and pencils ready. The basic principle behind hot air balloons. Pencils up. 3, 2, 1. Waiting on 2. Just want to make sure that everyone is underlining key vocabulary. Back to it. The basic principle behind hot air balloon physics is the use of hot air to create buoyancy. See Chris underlined the word buoyancy. See Nia has underlined it, which generates lift. A hot air balloon consists of a large bag called an envelope with a gondola or wicker basket suspended underneath. See Niles underlining suspended. Jeffrey underlining suspended. A burner sits in the basket and is used to heat the air inside the envelope through an opening. This heated air generates lift by way of a buoyant force. See Rendell underlining buoyant force. Jeremiah already has it underlined. The hot air inside the envelope is less dense than the surrounding cooler air. This difference in density causes the hot air balloon to be lifted off the ground due to the buoyant force created by the surrounding air. The principle behind this lift is called Archimedes' principle. Repeat after you hear me snap. Archimedes' principle. Archimedes' principle. Which states that any object